Hi, this is a commentary on a transition metal question. It's taken from the AQ specification. It's a year 2 paper and it's year 2 content. Question 6.1 was a redox titration calculation. Question 6.2, as you can see here, is asking us to identify two ways in which we can reduce the volume of sodium thiosulfate. So just for context, copper atoms existed first of all in an alloy, and they were oxidized to make copper 2 plus ions. The copper 2 plus ions were then converted into iodine, and then the iodine was titrated against thiosulfates, which is the S2O32- on the left hand side of the second equation. So the thiosulfate was added from a burette. So the volume of thiosulfate is measured using a burette. The average titer was 9 centimeters cubed. Now a burette generally can measure up to, well, it's 50 centimeters cubed burette that we usually use, and we'd like to use, in excess of 50, maybe 25 centimeters cubed. So that's quite a low titer. The uncertainty of that burette reading can be reduced if we use the burette to measure a greater volume. So how can we increase the volume? Two ways. The first way is to use a lower concentration of the sodium thiosulfate, so decrease the concentration of the sodium thiosulfate. Also, the sodium thiosulfate will react with more iodine if there's more iodine presence, and because the iodine is formed from the excess iodide reacting with copper 2 plus ions in the first place, if we can put more copper 2 plus ions in the conical flask in the first place, that will also increase the titer. Now the copper 2 plus ions originally started in the alloy, so we could increase the mass of the alloy that we used. So that's the second way that we could decrease the percentage uncertainty of using the burette to measure the volume of sodium thiosulfate. So the next part of the question, 1 mark, to state the role of the iodine in the reaction with sodium thiosulfate. If the iodine wasn't there, we wouldn't be able to use a starch indicator to see the endpoint, because iodine in the presence of starch goes a very dark blue or black. However, this question is more about the oxidation reduction which is taking place. Remember, this is a redox titration. So the iodine goes from an oxidation state of 0 in the second reaction to an oxidation state of -1. So the iodine is reduced. That means that the iodine is an oxidizing agent. That is the role of the iodine. The iodine is an oxidizing agent. So the next part of the question requires us to give the electron configuration of a copper 2 ion. You first have to know the order of filling of shells, and there it is. You fill the lowest energy subshell first, then you fill subshells singly until they have to be spin paired. 4s is filled before 3d, apart from in the case of copper and chromium atoms. Now this is a copper ion, not a copper atom. But in the case of copper and chromium atoms, the 3d can be filled evenly with a single 4s electron, so 4s1 3d5 or 4s1 3d10 for copper and chromium atoms. The 4s is always lost first when forming ions. Now that is relevant in this particular example. So there is the electron configuration for copper. You can work out the number of electrons from the proton number, which you can get from your data sheet. It's on the periodic table. So that would be the electron configuration of a copper atom in red there on the right hand side, and you can see that the 4s is filled evenly, giving us 4s1 3d10. But remember that we always lose 4 electrons first when forming ions, so the 4s electron is lost first of all, and then one of the 3d electrons is lost, so it ends in 3p6 3d10. Okay, so now we have to explain why copper 1 iodide is white. Well, white is not coloured, so why is it not a coloured compound? Coloured compounds form when the energy absorbed by electrons when they transition from the ground state to an excited state is in the visible region of the electromagnetic spectrum. If the d subshell of a transition metal in a compound is incomplete, the compound will be coloured because the energy which is absorbed is in the visible region. However, copper-1 ions do not have an incomplete d subshell. Copper-2 ions do, but copper-1 ions have a complete d subshell. So copper-1 ions cannot absorb visible light.